Note on the question. So in this class, we will solve one problem related to rigid frame. Analyze the rigid frame using moment distribution method. A, this is B, this is C, and the term is D. So first of all, we'll calculate fixed end moments. So the first one, fixed end moments. So MFAB is equal to minus WL squared by 12, as it is a fixed one, minus UDL is acting minus 2 into 4 squared by 12. So minus 2 into 4 squared by 12, so which is minus 2.67 kilometer meter, that is MFAB. MFBA is also the same, plus WL squared by 12 plus 2 into 4 squared by 12 plus 2.67 kilonewton meter. So which is fixed end moment. Now in this, fixed end moments are calculated. Now we can see here MFBA is calculated. Now coming to this portion, here in this one, that is not fixed. You need not calculate here the fixed end. MFBC is not to be calculated, but here I will see for BD. So when BD is calculated here in this portion, when a loading is coming, the deflection profile will be like this. So to resist that one, here the moment will be there like this, and here the moment will be there like this. So here, if you observe, it is anti-clockwise direction, and you can simply take it as a beam like this. This support is B, this support is D. So this is like this. So that is BD, 4 kilonewtons load is acting. So with this, MFBD is minus WL by 8. So minus, the point load is 4 into span is 4 by 8, which will give you as minus 2 kilonewton meter. So MFBD is minus 2, MFDP is plus WL by 8. So plus 4 into 4 by 8 plus 2 kilonewton meter. As this hanging portion is there, so for this this moment, external moment due to the point load will be like this, which is 2 into 2, 4 kilonewton meter. But at support B, the resisting will be there in this direction like this. Like this. So the resisting moment here, it will be MBC is equal to MBC is equal to, so that is anti-clockwise minus 2 into 2 minus 4 kilonewton meter. Kilonewton meter. So that's it. Now we'll go with the distribution factors. So writing down the distribution factors. So at the joint B, here only joint B is there. So just first of all, at the joint B, we'll write down what are the beams that are available here, which is a fixed one. The far end is fixed here. This is A. This is also fixed here at D. C is there. And now in this member, what is the length of this member? 4 meters, and the moment of inertia is 2I. This is I comma 4. This is 2I comma 2 meters. Now in this, just see this one. We need to write down the relative stiffness of the members. So when you write down the relative stiffness, KBA is equal to, as this is joint B, the far end is fixed, so this will be written as I by L, which is 2I by 4. That means I by 2. So the relative stiffness of KBA is 2. Coming to KBD, which is also I by L, as why? Because the far end is fixed. So here when the far end is fixed, it indicates that that is I by L, which is I by 4. Here the moment of inertia for BD is I and the length is L, so I by 4. That is the value. Now coming to KBC. Now KBC, when you are writing for the relative stiffness of the member, here the far end is, there is no support. But then hinge support is there, you might have 10 3/4. But here there is nothing to write on, hence it will be written as KBC will be taken as 0. So as the support C is no support is there at C, hence the relative stiffness of BC will be written as 0. So when relative stiffness is there, now writing down the distribution factors for BA is equal to KBA by KBA plus KBC plus KBD. So the relative stiffness of BA is I by 2 by I by 2 plus 0 plus I by 4. So you will get the value as I by 2 by 3I by 4. So which is 2 by 3. Just check this one. The distribution factor for BA will be 2 by 3. Distribution factor for BD is equal to KBD by KBA plus KBC plus KBD, which is KBD is I by 4 by I by 2 plus 0 plus I by 4, and this will be 1 by 3. So distribution factor for BC is equal to KBC by KBA plus KBC plus KBD, which is 0 only, 0 by 3I by 4, which will give 0 only. So as the support C is not available, as the far end is either not fixed or hinged, you can consider it as and you can see here the distribution factor will be 0 for BC factors. So in the fixed end moments, what is the at AB? What is the moment? Fixed end moment is minus 2.67 kilonewton meter. Minus 2.67. What we have written? Have we written the same thing? Yeah, minus 2.67 kilonewton meter. MBA is also plus 2.67 kilonewton meter. MBC is nothing but MBC, just take it -4. MBC, you get it as -4. MBC, you get it as -4. And in this fixed moment, the next one is MBD. So MFBD value is -2. MFDB is +2 km/meter. So here a slight difference is there in the previous problems as well as solving this problem. In the previous problems, we used to consider only a beam like this. So whatever the overhanging moment is there, we equated that to this. This is a support. So for example, if you got -22.5 kN as the overhanging, it is the moment at this support due to this overhanging, and this support will, for the joint condition, we made it as at this one. This is +22.5 kN. But now coming to here. Here another member is also there. 3 members they are meeting. So when 3 members they are meeting, now first of all we have to write down the balance. So which one we are balancing? So which one we are balancing? That is very, very important at this point. Either can we balance? So here AB is a fixed one. So this joint D is fixed, joint A is fixed. So we need to go with the joint B only. So when you go with joint B, now, so what is the difference? So take the joint condition is to be satisfied. That we already know that one. So joint condition is to be satisfied. MBA plus MBC plus MBD should be equal to 0. So to make it equal to 0, now we will calculate everything. And can anyone of you tell me what is this value? So -6 plus 2.67, which is
-3.33.
-3.33 is the difference. That is, after summation of these three things, it should be equal to 0, but you got a value of -3.33. So take the opposite sign, that is take +3.33, and this is to be distributed among multiplying with this, whatever the value is there. This is the balanced one. So this balanced moment is to be balance B. So we are balancing B. So joint B is to be balanced. So +3.33 multiplied with the 2, the distribution factor. So if you multiply with the +3.33 into 0, you will get 0 only. That is no use. So this is +3.33 into 1/3. So whatever the joint condition that is to be considered, and to make it to 0, you have to add with +3.33. So that now when you are balancing, so carryover moment will be there. So this carryover moment will be half of that moment. Is for BA, the far end will be AB. So here this will be +3.33 into 2/3/2. 3.33 into 1/3/2. So that is the carryover moment. So after carryover moment is completed, now just see it whether these supports are balanced or not. When the supports are balanced, then this will become as final end moment. So just add -2.67 plus 3.33 into 2/3/2. So these are the final end moments. MAB is equal to -1.56 kN/meter for this frame. Just see how I will draw this Venn diagram for this frame. So first of all, we'll draw our frame. Then for this frame, we'll draw Venn diagram. So in this, first of all here, this is the frame of this. So we will draw the positive bending moment diagram, which is WL square by 8. So for positive bending moment diagram, the value is WL square by 8, which is 2 into 4 square by 8, which is 4 kilonewton meter. So that is 4 kilonewton meter, which is a parabola. So this is plus 4 kilonewton meter. Now in this, another one is there. This is 2 kilonewton meter. That is a negative bending is acting. We'll come back to this overhang portion later on. Now see this. A 4 kilonewton is acting, which will give you a point load, that is WAB by L or WL by 4. So 4 into 4 by 4, which is 4 kilonewton meter. So this is also 4 kilonewton meter, which is a triangular loading due to point load. So this is 4 kilonewton meter. Now afterwards, we have to draw, this is positive bending moment diagram. Over this positive bending moment diagram, we have to draw negative bending moment. So this is 1.56 kilonewton meter, and here it is 4.89 kilonewton meter. Why? Because MAB, you can see the final end moment is 1.56 kilonewton meter, and this is 4.89 kilonewton meter. So this is 4.89 kilonewton meter. Now you have to join them as a straight line. Now after this, just see this one. Now come back this. In this one, what is the support moment at this? 0.89. MBD is 0.89 and MDB is 2.56. So just check the values with your 2.56. So this is 0.89, this is 2.56. So this is 2.56, this is 0.89. So you have to join them with a straight line like this. So now in this, now overhanging portion is there. We know that overhanging portion will give you hogging moment only, and that is negative bending moment. This 2 into 2, 4 kilonewton meter, which is here like this. Straight line. So this is negative, this portion is negative, this is positive, this is negative, this is positive, this portion is negative here, this is negative here. You can check it. Now if you hatch the portions where the bending moment is occurring, so this portion is the bending moment zone, and the remaining it is nullified. So you know that where there is the bending moment is becoming changing its sign, we call it as point of contraflexion. So this is bending moment diagram. Analyze the given rigid frame using moment distribution method. So this is the frame given, and for this one. Do it as a homework problem. I think on Thursday I have a class. I will check this problem. Otherwise, before that also you can send me this solution. Only few people they are sending the solution. What about the remaining people? Are you not doing the problem, or is there any difficulty in solving this, or sending me the solution? Why you people are facing any difficulty? Let me know. And today also the class, why the strength is very less, only they are 72. 72 they have attended the class. So you should be attentive and you should listen to the classes. Why? Because if you miss one class also, it will be very difficult. Regarding the attendance also, if you won't maintain, that will also be difficult. So now, do this problem. Just see this one. This problem. The thing is, it is also having a unit support. So the distribution factor will be there.